Hello, let's do an overview of Ethereum, the course, and the project we'll be building. The goal of the course is to learn how Ethereum works. More specifically, to learn how Ethereum works by actually coding a smaller scale version of Ethereum itself. So, to establish a good foundation, let's start things off with a definition of Ethereum. Essentially, Ethereum is a massive decentralized computer that serves as a platform for building decentralized applications. Within this decentralized computer, Ethereum has first-class support for a cryptocurrency, and it records all transactions on a public blockchain. As a decentralized computer, it has its own programming language, with a full set of features for mathematical operations, loops, conditionality, and more. This programming language is used to create smart contracts. Think of a smart contract as an account like any other within Ethereum's cryptocurrency. However, when someone transacts with the smart contract, it actually runs code. This opens a door to a wide variety of useful applications. For example, with smart contracts, you can build complex financial systems. These can be used to enforce the rules for insurance policies, to make investment decisions, or even to power gambling schemes. You can even build games on top of Ethereum like CryptoKitties. This game, based on purchasing and selling virtual cats on the Ethereum platform, went viral, as digital kittens became worth thousands of dollars. So it goes to show you that there's a countless number of use cases for Ethereum. Next question is, at a high level, how does Ethereum as a decentralized computer actually work? Well, as a decentralized computer, its code executes in a decentralized manner. Meaning, when code executes on Ethereum, it not only executes on one centralized machine, but all the machines in the decentralized network. To support this decentralization, Ethereum leverages its own blockchain. In general, even beyond Ethereum, blockchains are used as public ledgers of data, and most often, transactional data. As mentioned before, Ethereum uses the blockchain to store transactional data too, but the transactions stored in Ethereum aren't simple exchanges in currency like Bitcoin transactions, for example. They're actually transactions of state. Each transaction describes how a computer state should change. This allows everyone in the network to synchronize their computer state. By keeping their blockchains up to date, they'll also know what state transactions to run in order to keep their machine state up to date. And there you go. From a bird's eye view, that's how the decentralized computer and Ethereum works. This brings us to the main project of the course itself. The project is to create this decentralized computer. And the goal is to make this decentralized computer resemble Ethereum as closely as possible. Most of the data structures and even the names used for fields in the code will come directly from Ethereum documentation. The end result will be a system that includes many of the essential features that you find in Ethereum today. Therefore, the course curriculum is organized into sections that for the most part are centered around creating one more component that brings a project closer to the goal of creating an Ethereum-like decentralized computer. First, we're going to create the language for smart contracts. Next, we'll build a blockchain that applies the unique technical implementations of Ethereum. After that, we'll work on creating a system that can support a network of servers. That way, we can have multiple machines running to support the decentralized computer. Moving on, we'll work on the transaction and account objects. This will help support the cryptocurrency, and it will help describe how the decentralized computer state should change. Since, as stated previously, transactions actually record state changes in Ethereum. Finally, we'll build the state management object itself. And once all of these components are working together, we'll have achieved our goal of creating a decentralized computer like Ethereum. In addition, at the beginning and end of each section, I'll make sure to update where we are in terms of progress, and I'll provide even more details on how the next piece will fit in the big picture goal of the project. With that, let's start writing some code. For the first task, let's write the language that we'll use to power smart contracts.